Okay, welcome to this Texas Immersive workshop. I'll be going over some information I've collected on 3D modeling, specifically for immersive, but a lot of basics. So I'll start out with broad concepts. 3D modeling, what is it if you don't know anything about it? It's a digital representation of objects using 3D modeling software. So you can think of it as a collection of points that the computer keeps track of. So it can re-represent it on a screen, on a 2D screen from a 3D point of view. So how does the computer do this? It keeps track of vertices, edges, and faces to make up geometry or polygonal models. You'll hear these called geometry, polygons, meshes. So a vertex is a single point that has an X, Y, and Z value. And if it's animated, it also has those values change over time. An edge is the line that you see when you see 3D models like this. An edge connects two vertices. And a face is the interior shape created by the vertices and edges. And these are always exist on one plane, they're flat. And so when flat surfaces in a model like this are all covered, this forms the geometry face. So when we start to talk about how we use these vertices and edges, there's a few definitions. A Boolean operation is a mathematical system used to express connections between two things, really, or multiple things, but often just two things. You can use Boolean operations to add, subtract, and do unions. So if you remember any like discrete mathematics, this is about sets of points. You don't exactly have to know how these work to use them in your 3D modeling workflow, but you'll see that come up. Like here, you're adding all of these points to form one shape. Here, you're like subtracting one shape from the other to form points. And here you're only adding the points that exist, or the shape inside that exists between these two shapes. An extrusion or extruding is when you take a face and extrude it out or pull it out and add more dimension. This is a common part of the 3D workflow as well. And subdivision is when you add vertices and edges between other vertices and edges to make the shape of the geometry more complex. So this cube here on the far left is made up of only a few of these points and edges and only has 6 faces. But if you subdivide it, and in Blender, this is just called subdivision, you get more points, which makes the geometry more complex. So you can do more interesting modeling with it. As you can see, this has a low face count, which means it looks really blocky. And this will not take up much graphics processing on a rendering computer. However, when you get a lot of these faces, this takes a lot more graphics processing, but you get a nicer shape. And this will be important when we talk about 3D modeling in an immersive context in a bit. And so when we think about the workflow of 3D modeling, we think about putting colors and patterns on 3D models. And this process is called UV mapping and texturing. A texture is basically the color data that you see here that goes on a 3D model. But it's not so straightforward that you can just think about where this color goes. You have to create a translation for the color to go on to the model, and that's called a UV map. UV maps can be kind of confusing, but it's a very standardized process, and often you'll just be modifying UV maps rather than creating your own, especially if you're working with something you've downloaded off the internet. So it's just important to know that UV maps always exist in a square space, a 1 by 1 or a 0 to 1, a 1 by 1 square. And this is just a way for the computer to translate raw color data to a location in 3D space. And then shading is the depiction of depth perception in 3D models. So as an example, this looks like what we've been talking about, where you can see vertices and edges and faces. But if you want to see a smooth surface, do you need a lot of points, like many, many, many points? Well, actually, there are algorithms that do this automatically. For example, this is a Phong shading, so that you don't have to add a ton of points here to see something smooth. There's actually algorithms that figure that out when you render it. So there's different ways to do this. In Blender, this is called smooth shading. In Maya, this is called like smooth. I'm not exactly sure, but this is important because you don't want to end up adding a ton of, you don't have to add a ton of faces and vertices to actually get a smooth object. So there's a few different steps that go into 3D editing. There's modeling, which is mostly what we've been going over, adding vertices and edges to create a 3D model. Texturing, which is the process of adding a UV map and color data to that to actually add color to the 3D model. You can think of this as the skin. And then rigging and animation are more for if you are animating a skeleton, like Shrek here. Rigging is the process of adding like a bone set to usually a humanoid character like this, but also could be like an animal. And it's basically just a way to hierarchical designate different points in the skeleton so you can animate it quicker. Animation is adding a fourth dimension to 3D modeling. So instead of just an X, Y, and Z point, you have an X, Y, and Z point for each point in time, T. And these are accomplished using keyframes. This is similar to if you've ever used any After Effects or video editing program where you add keyframes. And then the last step is rendering, where you actually get the computer to work the hardest in actually solving what all of the texture looks like with light simulations and texture simulations, and that's what the final product usually ends up being. Okay, so when we talk about 3D editing programs, there are a lot out there. They differ in different ways, but they all use all the conventions that I just talked about. So there's a lot of crossover. One of the industry standards is Maya by Autodesk. This is used for anything from architecture to video editing to animation to rendering clothing even. Maya is good for a lot of things. 3ds Max is a more advanced version of Maya from what I understand, but it's also used in gaming and animation and architecture, but it's also Autodesk, so I assume that there's a lot of crossover. I haven't used 3ds Max. Cinema 4D is used a lot for effects and scripting. You can get some really nice renders out of Cinema 4D. There's a lot of rendering engines that it comes with. But what I want to talk about the most is probably Blender. Blender is free, which means there's no barrier to entry. Will allegedly always be free. I think it's pretty good for beginners. It can be confusing at first, but that's just working in 3D in general. There's a lot more, but I use Blender the most. And then I know a lot of people use Maya, and I have heard from certain immersive people that 3ds Max is a very good tool as well. So the first thing we need to talk about before we get into the details are the file types. 3D objects come in a variety of file types. The most common ones you'll see are FBX and OBJ. First, I'll talk about STL. I think this is used for 3D printing, and that needs to be a little bit different because you're working in the real world. So if you're using 3D printing, you'll use STL as your output. FBX and OBJ are both, and 3ds are just all used for 3D objects. Some of these can also contain animation data as well, and texture and color data. I think the most common file type I use these days are FBX, which is created by Autodesk, I believe. And this will work in any program that I've ever used. It works in Cinema 4D, it works in Blender, it works in Maya. This is the most common one you'll see. I've never had any problems with FBXs. And then project files, a Blender file is a .blend. This can contain also animation data, but also just the whole scene, any tools that you use or unuse. A .ma is a Maya file, and a .unity is a Unity file. And I haven't talked about Unity yet because it's a 3D gaming engine rather than a modeling engine. But we will use it when we're creating Zepto objects. And so that's why I'm mentioning it here. So 3D in the immersive context. First, I want to talk about why graphics are so good and why they're getting better. It's because of a hardware technology called graphics processing units, or GPUs. Most computers have, all computers have CPUs. This is what runs the computer and does each minuscule calculation, like very basic calculations. And CPUs are really good at doing those small calculations really fast in series, but it can only do one task at a time. And so graphics, the calculations are often not that complicated, but you have to render every single pixel on a screen. So you have to do a lot of these very small calculations all at the same time. And so GPUs, graphics processing units, are really well equipped to do these many small tasks at the same time very efficiently. So we get really nice things like this screenshot from Unreal Engine 5, where you can get these crazy, and this is, shot in real time. You can get crazy lighting effects, very detailed, and those keep getting better. So 3D modeling is not going away. It's getting more and more advanced. But when it comes to VR, you might notice that VR graphics in a lot of cases are not as good as what you might get on a high-end gaming PC. And that's because a high-end gaming PC has all the hardware to render out 60 frames per second or even higher 1080p graphics with nice lighting, while something like the Meta Quest 2 is self-contained. It doesn't have the same hardware. It doesn't have the same storage. So you get something that looks like it's maybe 10 years old in some cases. But of course, this will also get better with time. And then I wanted to mention AR 3D. So there's a lot of tricks and kind of shortcuts that AR 3D developers commonly use. For example, this here is a generic looking kind of like shiny face filter. I think this might be Instagram. And you can get away with running something like this at 30 frames per second on a phone because these reflections that it's producing are pre-generated basically. It's not taking in the actual reflection map of the scene because it can't actually see what's around you. It's using smooth shading like I talked about earlier. So it doesn't have a bunch of points here. It just uses algorithms to kind of make this smoother. But there's a lot of tricks that AR 3D programmers use to help their efficiency. But mobile AR is also getting better every day. For example, Snapchat. Snapchat is really leaned into AR filters. For example, you can see this is a picture of the Snapchat Studio editor. You have a basic setup of a camera, a light, and a scene. And then in the middle, you have the 3D object. And so what this does is this camera acts as the camera on your phone. The scene, it matches the floor plane of the scene to the floor plane of real life. And then you get to see your 3D object as if it were in the real world. So the Snapchat Studio is a really, really advanced tool for creating AR filters like this. And if you want to know more, we're going to dive into depth on Snapchat Studio and using the Spectacles, which is Snapchat's AR glasses, in 2 weeks during the Social Good Hackathon or Buildathon, whatever we're calling it. Another use case is Zepto Studio. So anyone in the immersive class we've already talked to Zepto. Zepto is a social mobile app designed for social activities. There's a kind of like a TikTok type feed that it uses. There's AR filters, there's 3D clothes that you put on your character. So it's a pretty expansive app, but we will be talking about it specifically when it comes to 3D modeling clothes. So the workflow for 3D modeling clothes in Zepto, and I'll go through this kind of fast because I already gave this talk to the immersive class, it uses Unity, Zepto Studio files that you download, any kind of 3D modeling tool like Blender or Maya, and then you'll want to use an image editing tool for creating those textures or that you'll put on the UV map. So the workflow for this, and this isn't typical, or this is typical for a game environment, is you will create the 3D objects in a editor like Maya or Blender. And this is pretty intensive, especially when it comes to Zepto. Well, it's the most intensive part. You won't need to do any rigging, or you'll probably need to do a little bit of rigging. Actually, don't remember what the workflow is for Zepto, but mostly it's moving points around in 3D space and mapping the texture correctly. From there, you'll go to Unity, which is the game engine. And I'm pretty sure this process is pretty standard. You just import the file you made in Maya or Blender and then export it to .zepto, and then you upload it to Zepto Studio. Like I've mentioned before, when it comes to 3D modeling, there's a large emphasis on having a good GPU or graphics processing unit. And an average MacBook that's pre maybe 2017 is not going to be up to the task for this, or even a Windows laptop from a couple years ago. If you have the newest Mac M1 laptop, or you have a desktop Windows computer or a powerful, video editing or gaming laptop, it could work. But there are plenty of computers on UT campus that have a lot of this software loaded on. Most computers I've been to in CMA have Maya, Blender, and all the Adobe apps that you'll need. And you can check this at Moody, like about building. There's a lot of other websites like this in the UT system for other computer labs on campus. Many computer labs don't require that you are like a student of that college to use, some do. But if you don't have a computer that will support you doing any kind of intensive 3D modeling, there are plenty of computers on campus. The only thing I would recommend is that you bring a external drive, like a large flash drive or an external hard drive, to save your progress when you're using a campus lab computer. Here's a little bit of information on how powerful your computer might need to be to run this, but the short of it is, if you have built your own desktop computer or you bought a gaming computer, you should be good. If your computer is old, you probably won't have enough rendering power to really make the most out of your time 3D modeling. So check out the labs on campus. There's a lot of lessons online when it comes to 3D modeling. I haven't done this Maya one, but there's the famous Blender one, which I have worked through, and the communities for 3D modeling are pretty nice and helpful. I recommend working through the, especially the Blender one I can speak on. It's really well put together and doesn't throw too much at you at once. When you're going through it, it might even feel slow, which is nice in some aspects, but you're learning fundamental skills so that you can get creative later. And then I'll mention some common mistakes and solutions. I have never met a 3D modeler that doesn't use references in while they're modeling. This is important because when you open up Blender, like I have Blender here, and you have like an open canvas, it's really intimidating to actually know what to do. So like if I have a cube, like how do I make this cube into a sculpture? It can be intimidating. So I would recommend using reference imagery, even if it's 2D. And you can import pictures into Blender as planes like this. So that can be helpful for modeling. Another issue that I've seen before, that I've done before, is creating too many subdivisions too early. If you do this, it doesn't add much. You'll get kind of distracted by how many subdivisions there are, and your computer will start to really run slow. So just make sure to work with as few points and then start to add them as you need them. And things like the Blender tutorial will talk about this, but just keep this in mind. Skip past that. So I wanted to show off kind of what Blender looks like, what the interface looks like, and how to use it briefly. So here I have opened a Blender file that was already created that has the TXI helmet. I think this might have been used for printing a trophy for something. But what we can see here in the middle is called the viewport. In most 3D programs, this is called the viewport. This is a 2D render of 3D space. I'm navigating around by pressing the middle mouse button, which brings me to mention that if you don't have a 3-button mouse, you will definitely want one. All of these 3D modeling programs are designed for using a 3-button mouse, definitely. Really recommend getting a mouse. It doesn't have to be a fancy one. It's nice to have one with a middle button, because in Blender, that's how you move around. I'm pressing Shift to pan. I'm just pressing it and moving to rotate. And then I'm rolling the middle button to zoom in and out. Navigating is the first thing that you need to learn how to do when you want to 3D model in a program like Blender. So definitely get used to that before you try to press any buttons. And it can be tricky. One annoying thing that I've realized, and many people have realized, is there's no really standardized way to navigate through 3D space. Some programs do it differently than other programs, which can make things tricky. So I would stick to using one 3D modeling program like Blender. I would recommend to start with, so you don't get too confused. So what else is on the screen? There's a bunch of typical file edit options up here. We'll get to those. There's a bunch of tabs right here. There's a bunch of information within this viewport that I can cover too. There's information over here. There's something that looks like a timeline down here. And there looks like an organization tool over here. And then there's another set of tabs with data in it here. So each of these, you can see these rounded corners. I'm not sure what Blender calls it, but these windows, I'll call it, I think they're just called windows, yeah. These windows are all contextual. So doing some things while you're like clicked in this window can be different than if you do things like like copy and paste, for example. If you command C and V while you have this selected here, it might do something than if you have something selected here. So make sure you know what window you're working in. So let's go through some of these crazy settings. File, edit, render, these don't change no matter what context you're in. File has things like opening files, saving files, linking files, importing and exporting files. Import is how you would bring in for example, an FBX or a OBJ, or even an SVG or a picture. Importing, you can't, well, at least on my computer, you can't drag and drop like FBX files into the viewport. You have to import it because you will get some options that come up. For example, if I want to bring in this shape1.fbx, it had, oh, well, I didn't really show off what I did. You have all these options over there that you often won't need to mess with unless you know what you're doing. For example, sometimes objects will come in flipped or really big or really small. And you can choose it to bring it in with the animation data or not. So it has to go through those settings before you can import something. But I've imported earlier this TXI FBX. And so I'm just looking at it now. So that's the file tab. There's an edit tab where you have things like, copy, paste, undo, redo, preferences. That's mostly what I use here. Render. This is if we want to print out a rendered image. Let's just click this and see what happens. Nothing much happens because, oh, there it is. So after a few seconds, it renders. and it pops up a new window. That's our render result. And you can see the camera was kind of pointed at here. And it looks weird because we didn't add like lights or background or anything. But this is how you render a picture. I usually just press F12 to do a picture, but it'll render it to this window. And then from here, you can save or save as. Window is how you organize all these different windows. I usually I'm not advanced enough to really get into modifying much of the windows. And then there's help, which are external links to like tutorials or the manual or stuff. So that's up here. This might bring up the splash screen. Yeah. So that's up here. So what do these tabs do? So these tabs are pre-built layouts that you can change, but I usually leave them as is. Pre-built layouts for different part of the 3D modeling process. So example, here we're in the layout tab, which is where you can see this viewport window. You can see this scene collection window. You can see this editor properties window. So you can see they have types here, editor type outliner. This is called properties. This is the 3D viewport. And then down here, you can see timeline. So these little tabs in the top left of each of these windows tell you actually what the window is. So if you flick through these tabs, you can see there's tabs for modeling, sculpting, editing, UV editing, texture painting, shading, animation, rendering, compositing, scripting. You can add more. So those are called workspaces. And so I mostly use the layout workspace. Sometimes I'll go into the sculpting workspace. And so you can see it changed around some of these windows. Sculpting gives you like these different tools for like, if you can think about physically sculpting an object. I'll demonstrate one here. Let's see what this draw does. Okay, not much. I'm not exactly sure what this 3D model I pulled in has already had in it, but this is where you would kind of think about physically sculpting your 3D model. This is nice if you want to work with these tools, and you will want to work with these tools. I use things like smoothing a lot, but this is where you'll actually do your sculpting. I guess modeling is built for, 3D modeling. It has some of these tools here, like extruding, like I mentioned earlier, adding things like bevels or smoothing it. There's a UV editing tab, so you know where the texture that you've loaded in goes. This is a little bit more advanced. I've never used texture painting, but it looks similar. Shading is how the color is actually applied. And if this node graph starts to look crazy, you don't actually have to use node-based editors to texture your model. It's optional. I'll get into that in a bit. But there's other things like animation, if you're making something animated, and then some other stuff. But these are called the, these are called the workspace tabs up here. I'm often fine sticking to layout and sculpting, but it really depends on what you're doing. Okay, so let's talk about each one of these windows. Here is the viewport, which I've mentioned before. There's a bunch of buttons up here. There's some tools right here. There's some information here. So I'll start in the top left. So the first thing that you will probably learn, or one of the first things you'll probably learn in the Blender tutorials, is the difference between object mode and edit mode. Object mode is how you keep track of and select all these different objects. You can see when I've selected it, it shows a glowing box outline around the object that I've selected. And consequently, you can see that when I select things, it shows it in the outliner here. So this is object mode. You can move things around with these tools here. You can see this is all one object, helmet 4. This is its own separate object. This text from helmet 4. Things can be grouped. Objects can be grouped. As you can see here, everything is within helmet 1. If I turn it off, it's gone. You can move, rotate, scale. Transform just also means move, rotate, and scale, but all together. So this is what you do in object mode. When you get to edit mode, this is where you actually see those lines from earlier. You actually see the vertices and edges. And this is how you change the vertices and edges. So your pointer turns into a marquee tool, which lets you select whatever you hover over in this box. So if I select everything, you can see that everything lighted up. Here's part of it. And this is how you actually start to get into 3D modeling. I'm not going to go into like the details of what each of these do because you can go through that in a tutorial. But this is edit mode. And one important thing to note is that things change whether you're in edit mode or object mode. So if you're like, why can't I select everything? It might be because you're in edit mode when you think you might be in object mode or vice versa. There's a few other modes. Sculpt mode is what is pulled up here on the sculpting tab. And so that's what's here. There's a few of these other tool tabs here. View, cameras, like do you want to view from the camera? Like what do you want to view in this viewport? Like how do you view from the camera angle? Well, you can see this is the view we got from earlier when we printed out what we were seeing. So there's a lot of things like that in this view tab. Select does typical select functions like select all, select none, invert the selection, like select the opposite of what you have selected. Like, do I want to lasso select? This might be familiar to you if you've used selecting in Photoshop or an image editing program. This add tab seems large at first, but this is how you add new things to your, like new objects to your scene. Like add a new cube, I did that earlier. Add a new sphere, add a cylinder, add a surface, add a curve. A meta ball is a object that can affect like physics. So it's just more geometry, but it's geometry that can like move other geometry around. Text is what it sounds like. Volume is for things like if you're making fog effects or fluid dynamics. Lights are for lighting your scene. Cameras for rendering your scene. And then I haven't used many of these other things. And then there's tools for your object like transform, duplicate, copy, paste, parent it, which I'll talk about organization here in a second. I mentioned shade smooth and shade flat. So you can kind of see that this is stylistically angled like this. But I wonder what happens if I shade it smooth. As you can see, those angles kind of disappeared because it's doing those algorithms and rendering so that it actually shows smooth, even though if I switch to edit mode, it still has the same amount of points and edges. But I'm going to switch that back to shade flat so I can actually see those edges because those were clearly intentional. And there's a lot of other functions here that have their own uses. I don't even know what many of these do. But oftentimes, if you need to know how to do something, it's just a Google away. So there's a lot in here. Orientation is how you orient the object in your scene. For example, you can see, I think this is called a gizmo, these little arms. At least that's what it's called in Unreal. But this shows you what your plane is. So it gives you some orientation when you're working in 3D space. In Blender, it looks like the x-axis is red, the y-axis is green, and the z-axis is blue. You can grab that and rotate it around. You can rotate with middle mouse and see it rotate around. And then you can see this gizmo here. And currently I'm on the move tool. So you can, if you only want to move it on the y-axis, you can grab it there and you can kind of see a representation of what track it can move along. I'm going to move it back. But that's, so orientation is actually like, do I want it to have its own local orientation? Do I want it to be on the X, Y, and Z plane of the whole scene, or do I want it to like have its own thing? And you can see that the rotate tool here and the scale tool pops up their own gizmos. There's more information here. There's these tools for object mode, like moving and rotating and scaling, which is all called transformation. There's some more information here that looks like it could be a repeat of some of that other information. I'm not sure what this is, just being honest. Another important thing though is this area right here, and it's easy to miss because it's kind of shoved up here. But what we're looking at right now is an unlit version of the scene, I believe, or let's see, it says viewport shading. So it's solid shading. And this is what you might imagine a typical 3D render and tool like this to look like. Everything is gray. You don't get like these colors. The background is gray, and you get like these lines for orientation. But up here are different rendering tools so that you can actually see what you're doing. This first one right here is wireframe viewport shading. So we'll switch that on and we'll see the actual edges and vertices of the 3D model. We'll switch that to solid so we don't have to see through it. But then the next two ones are actually doing some rendering. So this is the material preview tab. So you can see there was a gold material that's been put on it that's a little reflective. The statue base has a black material that's also a little reflective. And then the text has the same gold material on it. And you can see selecting all these, I'll skip ahead to this material properties tab right here. You can see that this one has the gold helmet material on it. This one has the black matte material. And so this final rendering is the actual rendering method. And so it'll take a few seconds to pop on, but this is what it actually looks like when you render it out. And we saw that earlier when I hit F12. This is what the actual final render will look like. Okay. I'm noticing that it's 2:50, so I'll try to fly through some of these other things right here. And let me know if you have any questions. I don't mind going a bit over as well, but feel free to leave at the end of the hour. So this is important to kind of orient yourself and see what you're doing. Let's see, there's an X-ray button so you can actually see through your solid materials. So that is working in the viewport window. I hopped over here to the, let's see, this is called the outliner and the properties windows, because you'll mostly be working between those three windows. So the last thing is this shows you kind of what tool you have selected. Demonstrate how to work with imported designs on Zepto. I don't have that planned, but I can surely try. I will just need to download the Zepto designs. So here in the outliner, you can kind of see a hierarchy of what you have in the viewport. You can add things together. Each of these symbols has a different meaning clearly. Like these are groups, these are lines, and then there's modifiers. And then this box means like a collection. So there's a lot going on here, but this is a way to organize everything that's going on in your scene. You can also see things like lights that you have in the scene. This light is currently right there in the middle, which it probably shouldn't be. And cameras as well. And that all lives under the scene collection. So this is how you if you don't want to search through your viewport to find something, you'll find it right here. A quick tip, this hides things in the viewport. For example, if I hide it here, it'll show selected. I can hide it, but this is to hide it in the renderer. So sometimes I'll hide things and then I'll hit render and they'll show up anyway. It's because hiding things in the viewport and hiding things in the render have different buttons. Okay, so down here at the properties window, again, there's a lot of tabs here and it looks intimidating, but each have their specific purpose, and you'll get into the flow of that pretty fast. So this is an active tool button. So for example, I have the move tool selected. You can kind of see some options here as well. This is repeat information because I have the tool tab open right here. This is the rendering settings. You see the back of a camera here. You choose your rendering engine, things like bloom or depth of fields. So this is where you want to change settings when you start to plan the final picture of your render. And so things like Zepto, you won't be rendering. You won't have to worry about rendering. This is more rendering properties. This is for output. So this shows like a little printer. You can choose how big your render will be. Here it shows up view layer properties. I don't often use this tab. Scene properties. You choose what camera you're using, what background scene. I don't often use this either, but in case you are doing something with architecture, you might need to change unit systems. Worlds, this is like basically all this gray space. If you want this to be a reflection map or like an HDRI, you'll come here and change things with the world tab. I don't often change this. And this is the object properties, which is probably where you'll be most when you're doing modeling. So for example, I have this text selected, and this is a text object, and it knows that. So it has things like transformation, where it is in space. And you'll notice a lot of these things that I'm changing here or here or here or here are a lot of repeat information. So it looks like there's a lot on the screen, but a lot of it is repeat because these windows are kind of agnostic of each other. Things like collections, these are called collections. Visibility, viewport display. Transformation is what you'll use a lot though, so you can see where things are. Modifiers is a big subject in Blender, but modifiers are basically how you do non-destructive changes to your geometry. For example, if I have this TXI text right here, I can add things like make an array of them, make 20 of them in a line that I know I want 10 spaces apart or something. Mirror, or can I solidify? A lot of these are like the generate tab. There's this deformation tab. But what these do are they're non-destructive. So if I want to, let's just see what bevel does. It's kind of hard to see if it did anything. I'll switch to the shaded tab. So I added a bevel modifier, and I can add some amount to the bevel, and I can see that it's doing something, but I'm not exactly sure what it's doing. But basically the benefit of using modifiers is that you can turn these on and off and reorder them. So if you decide that you need to change something later, you can come change it without it, being baked into the actual geometry. I'll do it on something that's not text. For example, this thing here. If I add a modifier that's maybe, I don't know what screw does, but it did this whole pattern here. I can just turn this off by clicking this button. And I can turn it off of the render. And so this is nice because if I go into edit mode, the geometry actually isn't affected by this modifier. So you can see those points and lines are still there, but it's generating that on top of it. So modifiers are what we call like non-destructive workflow. Okay, so moving on, there's things like, this is particle properties, probably won't need that for, especially for Zepto. These are physics properties. You definitely won't need that for Zepto. Constraints, those more physics. This green thing here is object data. So if it belongs to, this is more advanced too. This has like UV maps and stuff. Anything red here has to do with material. So as you can see, you'll probably be here a lot. There's a materials tab and you can look right there. It shows you what active material you have. And it kind of gives you some data on this material. It's using a GGX material or a principled BSDF surface, which is pretty common. You can change things like specular, this will all take like a separate session of learning what all these rendering words mean, all this vocabulary. But this is where you would get to material properties. For example, if I want to change this really fast, I can change like the color. It's pretty straightforward. So that's a quick overview of Blender and mostly this layout tab. The final thing you'll want to be able to do is export. So if I export it like this, just to show you that it's different, I'll export it as an FBX. It'll give you some settings here, like where you want to print it out to. I'll call it Helmet Trophy TXI Workshop. And then you can choose to include things like animations. I'm going to turn that off. Transform, but I'm pretty much okay to just press export. It'll do it pretty quick. And I'll check in the directory here and we'll see Helmet Trophy TXI Workshop.fbx. And if you're on Windows, Windows has a built-in 3D object viewer that you can pull up. And you can see here, since I moved the things around, they are where I expect them to be. So yeah, this is a quick overview of Blender, and there's a lot there. It's pretty intimidating. You don't have to know every single tab to use Blender very effectively. As you can probably tell, I didn't know a lot of like what a lot of this does, but typically my workflow is I'm not modeling things from scratch, or if I am, I'm following a tutorial. So number one thing is to just get situated with moving around in 3D. And then number two is basically finding good tutorials. I recommend the Blender Donut tutorial that's listed in the software skills. But yeah, I'm going to stop the recording and then I'll let y'all ask any quick questions. And yeah, Greg, I didn't get to, here, I'll stop this. Hello, everyone. This is a bit of a spontaneous video where I'm going to go through a little bit of the workflow that I found on how to import Zepto 3D models, how to edit them, how to see what you've edited, just in case you need some help starting. I just worked through the workflow myself, so this is the best idea I have on how to edit Zepto items, especially if you want to change the 3D model. So first thing that I did is I went to the Zepto website and I logged into Zepto Studio. And I want to look for, you know, an item. And the way that it looks like I do that is I hit create. I want to create an item, and I want to create, let's see, let's go with this shirt. So when I download this shirt, what I'll notice is it'll download a zip file. I'll open it up, and it comes with a PNG and a PSD. So basically 2 image files. And that's not very useful to me if I want to actually edit the 3D model. So what I have found is that there are a few pre-made files, 3D files in the guide here. I'm gonna have to look for it for a second because this guide is large. Okay, so here are some samples, and let's edit this jacket. So I'm gonna download that. I've already downloaded it, and extract it. And so you can see this one actually comes with a 3D object, an albedo PNG, which is color map, and a normal PNG, which is, you can think of that as lighting or shading, like shadows. So I'm going to extract this all, just keep it in my downloads, and it will open a folder. So the first thing I want to do is I will open a new Blender file. I'll delete this cube out of here, and I'll have an empty canvas. And in order to get this, let me close some of these for a second so I don't get confused. In order to get this FBX in here, and the FBX, as you remember, is the 3D file, I'll go up to File, Import, FBX. And in my Downloads folder, I have OTR52, FBX. I can leave all these settings as they are and press Import. And you'll notice a few things happened. A little Zepto model popped in. I'm getting 2 different objects. I can see the mask and the OTR52, which is this jacket, this bomber jacket. There's a lot of few other things here. There's a pose. These are represented by these triangular prisms with balls at the ends. Those are usually bone representations of bones in like a skeletal system. There's this other armature with some more bones. But what I want to do is, let's say I want to edit the 3D model of this jacket. I would select this jacket, and I need to go from object mode to edit mode, and I can actually see the geometry of this jacket. So maybe what I want to do is I want to change the, I want to do something simple and change the taper length of this jacket. So what I'll do is I'll drag my marquee here. You'll see everything is in orange. You'll notice it didn't select everything I wanted. I think there's I think Control L. Okay, so Control L, which is just what I hit, selects everything in like a line that you've selected. So if I just select these dots here and hit Control L, okay, I'm not exactly sure how to use that shortcut. There's a lot of shortcuts in Blender. So I'll just do this manually, which is not the best way to work, but it'll work for me for now. See, as you can see, me doing it manually, I accidentally got these other spots. So I'm control selecting to deselect them. So if I was doing this very methodically, I would figure out how to just select all the points I need. But since this is just a demonstration, I'll just kind of do this quickly. I'll deselect these as well. And that's by holding Control Select, and this is Shift Select to control to select multiple, to add them to your selection. That's probably close enough. There's probably some other random things in here that I selected. But that's close. So I want to change this taper. I'm going to select the move tool and let's just move it down a little bit. Let's be dramatic so we can see the difference. And then I'll go out of object mode. And sure, let's say that's exactly what I wanted to do. So we're done with the 3D modeling part of that. You can switch over here to see what the viewport shading looks like. And the first thing we'll notice is that it's still shaded gray. Like it's not really showing us this color map that we downloaded, which is right here. This is what we should be seeing on it. So why are we not seeing this? It's because the way that these Zepto models, I guess, are organized is that this FBX and this albedo map and this normal map are not aware of each other. Sometimes FBXs can be linked to, you know, normal maps and color maps, but for whatever reason, it doesn't seem like this one is. So when I'm modeling, I'm going to want to see an example of what I have done. So I'm going to go to Shading tab. It'll switch me into a different workflow where I can see my model. And I'll want to make sure that I'm going to be in viewport shading or viewport shading rendered, material preview or rendered. And so there's a few things on the screen. This is a viewport, and then down here is the material editor node graph. And there's a few things going on here. There's a material output. This is basically just the output, what is on the object that you've selected. As you can see, this is orange. So it's showing me this thing. You have to make sure you're in object mode. There's a BSDF, which is just the actual material itself, how it behaves in light, like specular, how much light it reflects. What's the base color? I can change this to yellow, but we'll keep it white for now. And then there's this node here, that's the normal map. And an easy way to describe a normal map is kind of like a fake way to see shadows. So if we look in the folder here at the normal map, you'll notice that it looks a lot like the color map, but it has some weird red, blue, purple action going on. And as you can see, if I make these larger, this is a reflection of this, but for example, this patch, we want this patch to kind of stick out like a patch would stick out in real life and have lighting effects, but we don't actually want to add that to the geometry. So what the creator of this jacket has done is, instead of adding, if we can check here, instead of adding points to the geometry, which would be costly and inefficient if you want to edit it later, what they did instead is in the normal map, they added these points where there would be light, and this is basically just the computer is able to read these red, green, and blue values in a way that reflects kind of like how much shadow is hitting, or how much light or how much shadow is in that particular place. And this noisy area right here where you see kind of like all this noise, this red and blue noise, that translates to kind of like a wrinkled looking jacket. Here, these lines I think are zippers, more patches here. But the question is, how do we create this? Because it's easy enough to open this up in Photoshop and change it. In fact, I think I'll do that now. This is a sock. What I did here is I used like a Photoshop magic eraser, I think it's content aware fill, to get rid of this patch here. Let's say you don't want it. So I got rid of it, I merged it together, and you see this jacket here now doesn't have this patch, but the normal map will still have this patch right here, and it won't look right because when I took out this patch, it's not actually going to be reflected on the jacket. You're going to see this kind of like shadow. And so I'll set that up for you here now. So if we go into shading, we'll want to add two things. I'll Shift A, which is the add menu, or you can hit add here. I tend to do Shift A, texture, image texture, and then drop that there with a left click. Connect color to base color, and you'll see it kind of change. But it's just changing to black because there's nothing there. So what I'll do is I'll open, go to my downloads, and I'll open the, let's see. So here's the color map, albedo, and you can see it pops on. So that works pretty well. And then you'll see this normal map also has an option for color. So I'll want to Shift A, texture, image texture, color, switch that over. It's gonna change again, it's compiling. Wow, that looks weird. That's because this image texture is empty. So I'll open this again, go to downloads, find this, and there is the albedo, or sorry, the normal. And now you can kind of see that rough look, which mimics shadows. Even on this bomber jacket here, you can see that the patch doesn't stick out like it would in real life, but it will probably be reflected by some small shadows. So you can kind of see that here. Interestingly enough, I actually realized that this demo, if you compare the color map to the normal map, you'll notice that the patch is actually in a different place than the anchor patch here, and you can actually tell when you look, you can actually kind of tell where it is. This is where the anchor was meant to be, and there must have been other patches here, but somehow it got switched up. So this is actually an issue with the demo file. So for example, if I wanted to fix that, or I wanted to change anything about the color and see it before I end up putting it in Unity and end up trying to submit it to Zepto, this is a much quicker workflow if I can just see it in Blender as I work. What I will do is, like for example, I just magic erased that that anchor out of there, and I'm not going to make the normal map myself. You can actually generate those with a couple of online tools. And here's one. What I did here is I just Googled color to normal map. This is the first one I found. There's a few of them. And it gives you a demo on what it does. It takes like the light and dark value and algorithmically produces this normal map so that when you view it in a 3D space, you can totally see there it looks like color, it looks like light is hitting it in a specific way. And it changes depending on where the cube is, or like where the map is. So normal maps are very essential to making, especially things for like mobile apps where you don't want a bunch of geometry or lighting calculations. And you don't have to make those yourself. I'm gonna open the second, okay, so I'm gonna open the one I did earlier, which is here. I made this albedo 2, which is this, I magic erased that anchor thing out of there. And I'm just gonna drag and drop it into this tool and hope it works. And it looks like it works pretty fast and kind of gives you a preview of what it looks like. And as you can see it spinning around here, it does look like it has some shadowing effects. So I'm just gonna download that. I'll download it into this new folder here and call it normal edited. Oops. It's just gonna download. Yeah, so then I'm gonna go in here, First, I want to switch my color map to the new one that I made, which is in a different folder. It's right here. And you can see it immediately updates, and you can kind of see that this would be a problem. You can kind of see these shadows where there shouldn't be. So I'm going to upload the new normal map, which is right there. And as you can see, it got rid of those like ghostly shadows. And this is my jacket. You can see this is a little odd right here because I stretched it out really far, and the UV map is still the same as it was. So that will be you'll need to take that into consideration. But if you're looking to kind of see what you are doing in Blender without having to go through the process of getting it into Unity and then to Zepto first, this is how you would do that. I'm not sure how well this tool works. There's different settings here too. Like I probably should have lowered the strength of it down, which means like how strong are those shadows actually. You can see here, this actually shows it too in 3D space. The jacket shouldn't be that strong. It's probably going to be pretty low, like below 1. Most clothing is probably going to be like that as well. And another thing you'll want to change is the level. The level is actually, I think the level is what changes the physical level. Oh no, that's the displacement right here. So you can see I turned it all the way off. Or actually I turned it negative. But these tools, there's a lot of these online. Oh, and look at that. You can even load in an object. So if you want to load in an OBJ of the model you're working on, you can do that and just see it in browser here. Yeah, and then there's blurring, and blurring might be nice if you don't want the it to be so sharp. That's probably nice on softer clothes. This is the tool you want to use to generate your normal maps, and you don't really need to think about this too hard once you've thought about it once for your object. Okay, and with that, hopefully this helps you get started on editing at least the designs of your clothes. If you have any questions, please message me and we can learn together. Thanks for watching.